Okay, so in our previous classes, we have discussed about the, mirror, plane mirror and spherical mirrors and what are the differences between these two, right? Then we discussed about the properties of plane mirror and also the properties of a spherical mirror and the uses of these mirrors in our day-to-day life also we have discussed. So now the concept is here, what are lenses and what are the two different types of lenses here? First, concave and the second convex lens, right? So from concave and convex lens, we have other types of lenses also. So we are going to watch a video related to this. What are lenses and convex lens and concave lens? And then we will continue our concept from book itself and exercise questions thereafter I'll be discussing with you. So let me share my screen now and first understand the definition of lenses, right? How we define lens. Can you see my screen?
Yes, sir.
Is it visible to everyone?
Yes, sir.
Okay. So let me include computer sound. Now here we have what are lenses, a video related to that. Then we will watch convex lens also and concave lens. So this is a 3 minutes 33 seconds video. First understand lenses.
Have you ever wondered why the faraway objects appear close to us when viewed through binoculars? What are the two transparent materials in front of the binoculars that make those objects appear nearer? And what is that we use to see very tiny things or to read text with small font size? Why do we wear spectacles? What's used in spectacles? The answer to all these questions in one word is a lens. The two lenses in the binoculars make the objects appear nearer to us. We use a magnifying lens to see tiny things and it has a lens in it. And there are two kinds of lenses used in spectacles. We wear spectacles if we are suffering from certain eye defects. If one is suffering from myopia or nearsightedness, we wear spectacles which have concave lenses in them. And if one is suffering from hypermetropia,
So if we talk about myopia, nearsightedness, you will study in detail about this, on the problem in people, those who suffer from myopia, they are able to see the near object. Nearsightedness means the people who suffer from this, they are able to see the near object, but they cannot see the clearly the far off object, right? So the objects placed it far away, they are not able to see. So that's why we call it nearsightedness.
or farsightedness, we wear spectacles with convex lenses. Lenses are also used in telescopes and cameras. So what is a lens? In simple language, we can say that a lens is a transparent material that bends the light in some pattern. The pattern in which the lens bends the light depends on what type of lens it is. Basically, there are two types of lenses: simple lenses and compound lenses. Compound lenses are made up of one or more simple lenses. For the moment, we're only interested in simple lenses. What does a simple lens look like? A simple lens is a transparent material which is bounded by two surfaces in which one of them is spherical and the other one can be either spherical or plane.
By observing this, you can understand here the from both side it is spherical, and it appear like that the two slices of of two different spheres, they have been joined through this middle line. Okay, so it is appearing like that, and this is transparent from one side to another side. So light rays from one side, either from left or right, will enter and will get refracted through this lens to the other side. So that is what this is an example of simple lenses.
Yes, one of them is definitely spherical and the other one can be spherical or plane. Let me ask you an interesting question now. With this knowledge, how many types of lenses do you think exist? There are 6 types of simple lenses. Yes, 6. And this is what they look like. Note that they are drawn in a two-dimensional space, but you can imagine their appearance in three dimensions.
So generally we have the convex and concave lens. So we call it biconvex because both side, is bulged outside, right? And it is called biconcave. So both side you can see it is bulged, it is, curved inside. So this is biconcave, and simply we call it, concave lens, and this is the convex lens. But depending upon the other, side of the surfaces on both side, we have these four types of, lenses. So that's why we say six types. Otherwise, in general, we can say only two lenses are there, biconcave and biconvex, or in a simple term, we tell that concave lens and convex lens.
A simple biconvex lens is a lens in which the two bounding surfaces are spherical and are curved inside. Similarly, biconcave lens is a lens with two spherical surfaces, both of them curved outside. For simplicity, instead of biconvex or biconcave, we call them convex lenses and concave lenses. Plano-convex lens is a lens in which there is only one spherical surface that is curved inside and the other surface is plane. Similarly, in a plano-concave lens, the spherical surface is curved outside and the other surface is plane. What about the remaining two lenses? The names sound fancy, right? In these two lenses, one of the surfaces is curved inside and one of the surfaces is curved outside. And hence meniscus is also called a convex concave lens. From all the types of lenses above, we are interested in only biconvex and biconcave lenses, which are also referred to as convex and concave lenses. In the next video, we will see how these convex and concave lenses refract light.
So this is what the basic, definition or basic types of lenses we have to understand. But in your book, you have been given about the convex and concave, both types of lenses. And we talk about here the lenses, are curved inward or curved outward in both, depending upon whether it is convex or concave. So you can say that a lens is made using the, two slices or two taking the two curved parts of the sphere, right? And they are joined together. So this is what you can simply define and say about the lenses. As we discussed about the mirror also, concave mirror and convex mirror, which are the part of the hollow sphere. But in this case, the sphere is not hollow. It is just like, apple, and from that apple, slices are taken and they are joined together. So in this way, you can define it. Am I audible to everyone? Am I audible or not?
Yes, sir. Yes.
Okay. Please turn on the camera and respond. Turn on the camera, everybody. Then we will continue. Turn on the camera. Your session is getting recorded. Everybody has to turn on the camera. Don't turn it off. Thank you, Vibhukant. Rest of you. Diya, Shreyal, Ishan. Everybody turn on the camera. Manya. Thank you. So I hope the basic difference or understanding you developed regarding lens or the mirror. Vibhukant. Got it?
Yes, sir.
Okay. So now your book talks about the convex lens and concave lens. So how we define between the difference between concave and convex depending upon their surfaces. So if I say that
Sir, yes, sir.
yeah, if I say that I have a convex lens, it means both sides. You can say both side is bulged outward. So this is the example of convex lens, right? And if I say concave lens, in case of the concave lens, it is, curved inside. Can you see it, all of you? So this is an example of concave lens. But in both the cases, we have the image formation, and the images are virtual, erect, or sometimes smaller than the object. So depending upon different situations and locations of the object from the central point of the lens. lens. So from the center of the lens, how far the object is located, it depends on that. So this is the concave, and this is the concave, and this is the convex. Basic, structure is like this: bulged outside, and this is curved inside, right? Now, related to this, we have a video and the image formation also. If we talk about what happens, about the images when the images are, formed by the convex lenses, right? So in case of the convex lens, and we have also read about the convex mirror. So we have seen that in case of the convex mirror, the image is always, in case of the convex mirror, which is the rear side view of the vehicles. So object is always smaller, erect. Inside the mirror, we have the image, right? In case of that. But if we talk about the convex lens, the image formation is always what? Real inverted. So we will watch a video related to the image formation and what is the convex lens, right? So is my screen visible now? Is it visible to everybody? Okay.
Yes, sir. Yes.
Okay, so please watch this video, convex lens.
In our previous video, we discussed about what a lens is and also its various types. It is bounded by two surfaces. One of them is spherical and the other? Yes, it's spherical or plane. These are the different types of lenses. The two specific lenses that we are going to cover in this course are called biconvex and biconcave lenses. Each one is bounded by two transparent spherical surfaces. Hence the word bi is used. It means two. In a biconvex lens, the two spherical surfaces are curved inwards, and in a biconcave lens, they are curved outwards. One more way to distinguish between a convex and a concave lens is that a convex lens is thicker at the center and thinner at the edges, while the concave lens is thicker at the edges and thinner at the center. Why do we use lenses? What does a lens do? In our previous video, we saw a few examples where lenses are used. In binoculars and magnifying glasses, for instance. But how does a lens function? Well, the main purpose of the lens is to refract the light in some pattern. There are basically two patterns, convergence and divergence. But before studying these two patterns, we first need to understand how the light is refracted by a lens. Consider a convex lens and suppose a ray of light is incident onto it at an angle. This is the normal at the point where the light ray is incident. Now consider a point object here from where this ray is emerging. What will happen when it enters the lens? This ray traveling from one medium to another at an angle, so after entering the lens, its speed will change, which will result in its bending. Will the speed inside the lens increase or decrease? And where will the light bend? Well, that will depend on the incident medium. Suppose this medium is air. So from this table, we can see that the refractive index of glass is much greater than air. This means that glass is optically denser than air. Hence, the speed of the ray of the light will decrease in glass, and because of that, it will bend towards the normal.
So we understand here the light ray is entering into the glass, and the glass is denser. The molecules of the glass are, very closer as compared to, it's a solid medium, and from the air medium to solid medium. So there is a decrease in the speed of the light, you can say, and that's why its path got, changed, and it bended towards the normal. So whenever from a medium to another medium light ray enters, there is change in its speed if it is, entering with an angle to the normal. So this is very important point you all need to remember, and you will study about it in detail in next class.
All right, So now what will happen when this refracted ray has reached the other spherical surface of the lens? From there, the ray will be refracted again as it enters another medium, which is air again. You see that this time it bent away from the normal. Can you tell me why? Air is optically rarer than glass, and hence after entering air, speed of the ray increases and it bends away from the normal.
So bending in the path of light ray is at a 2 points. First is when it enters from air to into the glass medium, and from glass medium it is going again into the air after refraction. So you can see it should go in that direction, but no, it went away from the normal. So again there is a change in speed, and that's why the path of the light got diverted. So this is happening in case of refraction. But in case of reflection, you already studied about the laws of reflection and what happens in that case. So reflection is a different term and refraction is another term. So we had already discussed about these two
And
terms
sir, the
earlier.
spelling of rare here is wrong. Sir, it should be Rearer.
Uh, uh, refraction, refraction,
No,
refraction.
sir, rarer. Sir, I am telling
R
about rarer.
R-A-R-E-R, rarer. That is written R-A-R-E-R, rarer.
Yes, sir, it should be Rearer.
You just understand it, R-A-R-E-R, rarer medium. So you can check the spellings yourself.
Yes, sir.
So voice is not coming.
Lens will be refracted in the same way. Did you see something strange?
Is it coming now? Is the voice
Yes,
coming?
sir.
Yes, all the rays meet at a common point. Or we can say that all the rays are focused or converged at a single point. And this is one of the patterns that we were talking about. Convex lens bends.
So here you can say that in case of the convex lens, all the light rays, coming from one side to another side, they meet at a point. So when they meet at a point, we call it converging lens. So convex lens is also called the converging lens. Is it, it should be very clear to all of you कि convex lens is called the converging lens. But in case of the mirror, if we talk about, so in case of the mirror, we have the concave mirror, which is called the converging mirror, because after reflection from the concave mirror, we have the converging of the all the light rays do converge at a point. They do meet at a point. So in case of the mirror, we call concave mirror the converging mirror, but in case of the lens, we call the convex lens as the converging lens. So this is the very important point you need to remember.
The light rays from a point object in such a way that after refraction, all these rays converge at a single point. And this is the point where the image of the point object is formed. If we were to place a screen here at this location, then the image will be formed on that screen. Since the convex lens converges all the light rays at a single point, we also call it converging lens. And what about a concave lens? How do they refract light rays? We will see that in the next lesson.
So I hope it is quite clear about the concave lens to everyone.
Yes, sir.
Okay, and there are many situations and the positions of the objects through which we get the image formation, which you will study in higher classes 8th or 9th. Basically in class 9th, you will study all in details, right? Can I ask you all to turn on the camera now? Keep your camera turned on.
Sir, my phone is on charging, so sir, I am not able to do.
Okay, so keep your camera turned on right now, everybody. So we understand here the convex lens. Now in my next class, I will be showing you the video related to the concave lens. Concave lens video we will watch in our next class. And we just see in our textbook what are the different things given to us. So here, these keywords everybody has to write and the definition in notebook, right? And there are many more points which we have not discussed. Activity 15.12 when how the white light gets different constituent parts. That is also a point we will discuss in our next class. Compact disc, what happens, okay, when placed in sun, and a rainbow formation. There is also a phenomena in nature that we call a rainbow formation. So we will study that. And sunlight, white or colored. So we all know the rainbow formation that is there in the sky, okay, when there is some refraction in the atmosphere, and light rays from the sun are passing through the tiny droplets of water, right? So during rainy season, or there is some kind of situation, weather condition where it appears like that it will be raining after some time. So in that case, the rainbow formation we see in the sky, and the splitting of the white light into its 7 color is called the spectrum. That there is a word from physics or science, we call it a spectrum. So spectrum is the word related to that. So these phenomena of refraction and reflection in nature we study in detail. You will go about the why the color of the sky is blue, why the sun
And so I think,
appear red in, yeah, tell me
so I
why
think
this.
Newton was the one to discover this as well.
Yes, Newton made a very
He did it with a prism of glass, I think, and then he wrote a
you're right.
theorem on it.
Yes, Newton made a very great contribution to the the discovery of this phenomena of rainbow. And the white light consists of 7 constituent colors, and we call it a spectrum. So Newton has done a lot of work on it, and this is discovered by Newton himself. So you can study about it in detail in just you can log in on Google, or you can find a book from library also, and you will study in higher classes. So till the point now, we understood about the definition of convex lens, difference between convex and concave lens, and also we got to know about the types of lenses depending upon its surface, both the surfaces on both side, left and right. So image formation, how images are formed, and how concave lens is different from convex lens. So all these things I'll be studying in, I'll be helping you to understand in our next class, right? So till this point, any doubt, please let me know from video, or the from lenses, or any other point. Yes, Vibhukant, or somebody else, please turn on the camera, everybody. Everybody has to turn on the camera. Yes, please, Vibhukant, ask me.
So the video that I want to share, so they have shown the practical project, sir, on the concave and convex mirror. So that's what sir, I want to show.
You want to show it?
Yes, sir.
So I make you the presenter, you can. Okay, just wait a minute. Wait a minute. You open it in your browser, and I just make you the presenter.
Yes.
How many minutes?
Sir, it's of, I think, yes, it's a 5 minutes.
Okay, now you can share it.
Yes, sir.
Make it full screen. So this is regarding defects of vision. Okay, so this you are going to study in detail in class 9th. Myopia, hypermetropia, right? And presbyopia. It's not running. The video is not running. I think sound is muted. Vivukant?
So are you able to hear me?
You are audible, but the video is not running and sound is muted. The video of the sound is muted.
So now it's running, sir. I think so. Just a minute, sir. I just mute myself.
Okay, okay. So you have seen this video, you found something interesting in it? You unmute yourself and sound, you have not included computer sound, I think.
Okay, sir. So just a minute. Yes, sir. Sir, there was a problem. Yes.
Computer sound आप okay कीजिए.
सर कर दिया सर मैंने कर दिया.
हाँ, अब play.
So I went to the doctor. When I was 10 years old, I realized that I couldn't see objects that were far away clearly. So I went to the doctor, and the doctor prescribed me spectacles. And I've been using a pair ever since. Now, if you don't use spectacles yourself, I'm pretty sure you'll know someone who does. But have you ever wondered about how spectacles work? Well, I have a setup here that might help us understand. The first thing we need to know is that spectacles are just a pair of lenses. And these two transparent pieces of plastic, they're lenses. And there are two main types of lenses. The first is a converging lens. Over here, I have a biconvex converging lens. Now look at what happens when I place it in the path of these rays. You see that? The rays hit the lens and then they get converged to a point. And hence the name converging lens. The other type of lens is a diverging lens. And over here, I have a biconcave diverging lens. When the rays pass through the lens, they get diverged. If you look closely, you'll notice that they look like they are emerging from a point behind the lens. Now, the human eye basically consists of two main parts: a biconvex converging lens, which we call the eye lens, and a screen, which we call the retina. So let's try to simulate the human eye over here. So let's say that this biconvex converging lens plays the role of our eye lens. Okay, and I have a screen over here that's going to play the role of our retina. Now, if you look closely, this is what happens in the case of a healthy eye. The rays come off objects, and then the eye lens converges those rays to a point on the retina. And therefore, this person sees a clear image. But then, sometimes there are defects. And the most common defect is called nearsightedness or myopia. In this case, the person can see objects that are close by clearly, but far away objects appear blurry to them. When this person looks at objects that are far off, those rays get converged to a point in front of the retina, like this. And therefore, he ends up seeing a blurry image. Now, this can happen for a variety of reasons. Maybe the eyeball itself is too large, or there's some kind of issue with the eye lens. Now, how would you correct this? As you can see here, it's happening because the rays are getting converged a little too much. So you need to negate that. One way to do that is to introduce a diverging lens. Now watch. Here I have a biconcave diverging lens. Look at what happens when I place it in front of the eye lens. Do you see that? The moment I place the biconcave lens, the rays now intersect on the retina. Now, this is because the incoming rays are first diverged by the corrective lens, and then the eye lens can further converge those rays onto the retina. So now, this person can see a clear image of those far-off objects. So this is why a person with nearsightedness requires spectacles with diverging lenses. So the other type of common defect is called farsightedness or hypermetropia. And this generally occurs when people get a little older. So what happens in this case is that when they see objects that are close by, they appear blurry, and objects that are far off appear clear. Now, when you look at their eye, this is what happens. So when these people look at objects that are close by, those rays get converged to a point behind the retina. And therefore, this person ends up seeing a blurry image. Again, this can happen maybe because the eyeball itself is too small behind the retina. And therefore, this person ends up seeing a blurry image. Again, this can happen maybe because the eyeball itself is too small, or maybe there's some problem with the eyelids. But how would you correct this? As you can see, the issue is happening because the rays are not getting converged enough. The eye lens requires a helping hand to converge the rays further. So therefore, we introduce a converging lens. So over here, I have a biconvex converging lens. Look at what happens. You see that? The moment I bring the lens, the rays now intersect on the retina. And this is happening because the incoming rays are first converged by the corrective lens, and then the eye lens can further converge those rays onto the retina. And therefore, this person can now see a clear image of those objects that are close by. So this is why a person with farsightedness requires spectacles with converging lenses. Make your child fall in love with learning. Download Byju's, your personalized learning app.
Very good. So I hope people have understood about the correction of the defects of vision.
Yes, sir.
Okay, so this is a concept, myopia and hypermetropia defects of vision class 9th given in NCERT, but by this video in 5 minutes, you understood the use of lenses and how we have the correction of these defects. So today I'm going to end my class here only. So we will continue our few topics, 1 or 2 topics are left, and then exercise question answers. Thank you so much.
Okay, sir.
Bye, sir.
Thank you, sir. Bye, sir. Thank you, sir. Bye, sir.
Okay, bye everybody. Thank you, Vivukant, for such a nice video.